Okay, let's talk about how SQL Server stores your data. Normally it uses something called a Rowstore. Think of a Rowstore like a phone book. If you want to find my information, you look up Ozar Brent. You find my name, and right there on the same line is my address and phone number. All the data for one person, one row, is stored together. This is great when you need to retrieve an entire row at once, like looking up a specific customer's order details. It's fast and efficient for that kind of work. A Columnstore index, however, flips this idea on its head. Imagine instead of a phone book, you have separate lists. One list has just last names, another list has just first names, a third list has just phone numbers. Each list is sorted. If you want to find all the people with the last name Smith, you only need to read the last name list. You don't have to wade through all the addresses and phone numbers for people you don't care about. This is the core concept of column store. Data is stored column by column, not row by row. This might sound a little strange at first. Why would you want to break up your data like that? Well, the magic happens when you run analytical queries. Suppose you want to calculate the average price of all products sold last year. In a traditional row store, SQL Server has to read every single row from your sales table. It has to pull the product name, the customer ID, the sale date, and the price, even though you only asked for the price. It's like reading the entire phone book just to count how many people live on Main Street. With a column store index, SQL Server can go directly to the price column's data. It completely ignores all the other columns. This dramatically reduces the amount of data it needs to read from the disk. Less data read means faster queries. It's a simple but incredibly powerful idea. This is why column store indexes are a game changer for data warehousing and business intelligence workloads, where you're often summarizing huge amounts of data from just a few columns at a time. It's built for big picture questions. Now that you get the basic idea, let's look at the two flavors of column store indexes. You've got clustered column store indexes, or CCI, and non-clustered column store indexes, or NCCI. The main difference is how they store the underlying data. A clustered index is the table. When you create a CCI on a table, you are fundamentally changing the storage from a row-based structure to a column-based one. There can only be one clustered index on a table because you can only store the data in one way. A clustered column store index is the go-to choice for massive fact tables in a data warehouse. Think of a table with billions of sales transactions or web page clicks. These tables are typically loaded with data in big batches and then queried for analytics. Since the CCI is the table itself, you get the maximum compression and the best query performance for analytical workloads. However, making frequent small updates or deletes to a table with a CCI can be a bit tricky, though SQL Server has gotten much better at handling this over the years. A non-clustered column store index, or NCCI, on the other hand, is a separate copy of some of your data. Think of it as a special-purpose secondary index. Your main table remains a traditional Rowstore, or maybe it has a regular Rowstore clustered index, but you create an NCCI on top of it. You can choose which columns to include in this index. This is incredibly useful for what we call hybrid transactional analytical processing, or HTAP. You have an active operational database that needs fast single-row lookups, but you also want to run analytics on it without slowing things down. The NCCI gives you the best of both worlds. Your day-to-day application queries can still use the efficient Rowstore structure, but when your CEO wants a dashboard showing real-time sales trends, that query can use the NCCI to get a speedy answer without dragging down the whole system. For example, a retailer might have an orders table as a Rowstore for processing new orders, but an NCCI on the order date, product ID, and sale amount columns to power its live sales dashboard. So what's the secret sauce that makes Columnstore so fast? It comes down to three key ingredients: compression, batch mode execution, and parallelism. First, let's talk about compression. Because data in a single column is often very similar, like a country column with many repeating values such as USA or Canada, SQL Server can achieve incredible compression rates. It's much easier to compress a list of repeating country names than it is to compress a row containing a name, address, and phone number. This means the data takes up way less space on disk and in memory. Next up is batch mode execution. With traditional row-by-row processing, SQL Server processes one row at a time. It's like an assembly line worker handling each item individually. Batch mode is a total game changer. It allows SQL Server to grab a chunk of data, typically around 900 rows from a column segment, and process that entire batch at once. This is vastly more efficient. It reduces CPU overhead and makes calculations fly. Imagine the assembly line worker can now handle 900 items simultaneously. That's the power of batch mode. Finally, Columnstore indexes are built to take full advantage of modern multi-core processors through parallelism. When you run a big analytical query, SQL Server can easily break the work into smaller pieces. Different CPU cores can work on different column segments at the same time. One core might be scanning the sale amount column for January, while another core scans it for February. Then all the results are combined at the end. This parallel processing, combined with the extreme I/O reduction from compression and the CPU efficiency of batch mode, is what delivers those 10 times or even 100 times query performance gains. Real-world scenarios make this clear. A bank analyzing millions of daily transactions to detect fraud can use a Columnstore index on its transaction table. A query that used to take an hour to scan for suspicious patterns might now run in minutes. A hospital can analyze years of patient admission data to predict future bed shortages. A query that aggregates data from admission date, diagnosis code, and discharge date columns becomes incredibly fast. These are not small improvements. They fundamentally change what's possible with your data. Let's talk about maintenance. With great power comes some responsibility. Maintaining Columnstore indexes is a bit different from traditional Rowstore indexes. In Rowstores, we worry a lot about fragmentation, where the logical order of pages gets out of sync with the physical order on disk. In Columnstore, we worry about a different kind of fragmentation compressed row group quality. Data is loaded into a temporary structure called a delta store before being compressed into row groups. Poorly compressed or small row groups can hurt query performance. To keep things running smoothly, you need to perform maintenance. Instead of defrag, you'll be using reorganize. The reorganize command has a special trick for Columnstore indexes. It can merge smaller, compressed row groups into larger, more efficient ones. It also takes care of moving data from the delta stores into a compressed state. Running a reorganize periodically, especially after large data loads, is a key best practice for maintaining peak performance. It's like tidying up your workshop after a big project. So, when should you use them? The sweet spot is for tables with over 1 million rows where your queries are doing aggregations on a small number of columns. Think sum count AVG. Don't just slap a Columnstore index on every table, especially small ones or tables with heavy OLTP workloads involving lots of single row updates and deletes. The overhead isn't worth it. Also, be mindful of composite indexes. In a Columnstore index, all columns are essentially stored independently. So the old Rowstore rule about column order in an index doesn't really apply in the same way. The bottom line is this. Columnstore indexes are a phenomenal tool for analytical and reporting workloads. They can dramatically speed up your queries, reduce your storage footprint, and enable you to get insights from your data faster than ever before. But they are not a silver bullet. Understand your workload, choose the right type of index, CCI or NCCI, and perform regular maintenance. Do that, and you'll be able to supercharge your SQL Server and make your data analysts very, very happy. Before you rush off to add Columnstore indexes everywhere, let's hit pause and talk about some common pitfalls and how to avoid them. First, remember, Columnstore indexes shine in analytic workloads, but they can actually slow things down for transactional tables with lots of frequent small updates or deletes. If your application relies on heavy OLTP operations, stick to Rowstore for those tables. Second, watch out for unsupported data types. Not every column can be included in a Columnstore index. Think large object types like text, ntext, or image. Always double-check your schema before creating an index. Third, be mindful of memory and CPU usage. Compressing and decompressing data is resource-intensive, especially during large data loads. For best results, schedule index maintenance and big data imports during off-peak hours. And here's a pro tip. Monitor your row group health with system views like sys.dm_column_store_column_row_group_physical_stats. This helps you spot inefficient row groups before they start to drag down performance. Finally, keep learning. SQL Server evolves, and so do best practices for Columnstore indexes. Stay curious, experiment in test environments, and don't be afraid to tweak your strategy as your data grows. With these tips in your toolkit, you're ready to harness the full power of Columnstore indexes without the headaches. Happy querying! Let's walk through creating a Columnstore index in SQL Server Management Studio. First, open SSMS and connect to your database. Navigate to the table you want to optimize, right-click and select New Index, then choose Non-Clustered Columnstore Index. In the dialog box, pick the columns you want to include. Typically, your largest fact tables with analytic workloads benefit the most. Click OK and SSMS will generate the TSQL for you. You can also use a simple script. Here's the basic syntax. Create non-clustered column store index IDX underscore column store underscore sales on sales, product ID, order date, amount. Just like that, your table is ready for faster analytics. Check the video description for the full demo script. If you found this video helpful, give it a thumbs up, drop your thoughts or questions in the comments, and subscribe to the channel for more practical SQL Server tips and tutorials. Your support helps us keep creating valuable content.